Question number 4. Ethanol reacts with oxygen gas to become carbon dioxide and water. So again, this is another combustion reaction. So as we know, combustion reactions we predict are spontaneous. The delta H is going to be very negative, large negative number because it's exothermic, releases large amounts of heat. The delta N is going to be, for the gas, is going to be -1. And so work is going to be done on the system. Positive work is work done on the system. Negative work is work done by the system. So let's calculate the delta H. So for water, it's going to be -285. For liquid water. This is different from question number 3 because question number 3 had gas, water vapor. Now we're looking at liquid water. Okay, so make sure that when you're looking at the table, you're looking at the right one. And then for carbon dioxide, it's going to be -39.351.51. Whereas the ethanol is going to be -277.69. And remember, for oxygen standard state, it has zero enthalpy of formation. So this is going to equal about 1366 kilojoules. Okay, let's calculate the change in bond energies. So let's draw out what ethanol looks like. So for these, you just have to know what the molecules look like, and then you can just look at the table for each of the bonds. So there's going to be 5 CH bonds, 1 CC bond, 1 CO bond, 1 OH bond, 3 O double bond to an O, and then we're going to subtract 4 C double bond to an O, right? Because carbon dioxide has 2, and then we have 2 carbon dioxide, so 4, and then -6, 3 times 2, OH for the water. This is going to be about -1258 kilojoules. Okay, let's calculate the change in the moles of gas. So here we're going to have -1. So work is being done on the system because we're going to have positive work. So this is going to be about, don't forget the negative here, and then we have 8.314 and times 300. This is going to be about plus 2.5 kilojoules of work. Let's also do the system really quick. So delta N of the system, this is going to be, so here we have 4 moles, here we have 5 moles, so this is going to be +1. So this is a little bit different from, because now we have liquids instead of just gases. Okay, so let's calculate. So remember here that for bonds, the bond energy, it's calculated by the bonds broken minus the bonds formed. Okay, always remember that. Write that down. That's an important formula to remember. So now let's calculate the delta S. So delta S is equal to 3 times 69.91, so that's water. And then we have 213 for carbon dioxide, minus 160 for the ethanol, and then minus 3 times 205. .14. So this is going to be about 138.91 joules per Kelvin. So now we're going to multiply it by the temperature. So 300 kelvins multiplied by minus 138.91. That's going to give us about minus 41 kilojoules. So let's calculate delta G. So delta G equals delta H minus T delta S. So we've already calculated all these, right? So minus 1366 kilojoules minus 41 kilojoules. This is going to give us about minus 1325 kilojoules. So this, as we predicted for spontaneous reactions, for combustion reactions, is spontaneous. This agrees with our prediction.